Hello everybody, welcome to another stream. How we all doing? There we go. Right, so last stream we started writing a parser for the the encoding system. So basically it's a C-like file. So it's just got a few little additions to it, so we can have little little parser directives or whatever you want to call them, to sort of say when we encode this thing as text, I want this as hexadecimal, for instance. And there's also support for these. You could put like a field name in the array syntax for a variable length array, which is kind of useful for like files and things. So we're currently parsing over this file, trying to just get all of the type information about everything, and then we can start writing an actual sort of serializer to serialize this stuff out to binary or text. But I've also been thinking as well off stream that this is actually going to have a lot of other use as well, because we have this sort of like packing thing, right? So here we're saying we're going to read it out as a U16, or the value we're going to pass into it will be U16 when we write it out. But it's going to actually pack it down into 8 bits, right? Within this range. So this could be useful for packing GPU data. So I could basically code gen bit packing stuff down so it fits into a very small area in memory, which is really useful for speed a lot of times on a GPU, and also for networking as well. There's more than just encoding data to files. It's going to probably be used for multiple things. I just got to figure out how do I do that. So we're just running on a parser today. We should hopefully get it finished and all tested out. We can have all the metadata around, and we can probably think about what is the best thing to do next. It's probably run one of the serializers. So it's just a simple like text reading system. We just scan over the text and parse it up and produce different data types and things and pick out values. So where we got to last time was, I think, the number parser. We haven't quite done this yet, but we're just going to support everything C does. So I think the easiest thing to do is just parse up, because I think we could just leverage the standard library functions. Right, it's a bit of a scrubby way of doing it, but it's probably the easiest way to do it. Does it say if it supports the F on the end? It might not. If so, we might just write it up ourselves. Because the 0x is supported for things, but maybe it... Oh, sorry, a string to float. Oh, yeah, no. Yeah, it's usually only string to double, I think. Yeah, they support that E syntax, right? So, or if not, we could just code it up ourselves, right? It's not too bad, I think. But I hope everyone's having a good day today. Everyone's had a good week. How's everyone doing? So yeah, I don't think this will support like the F syntax on the end, but I don't think that matters. We can just, then just use these functions and then just get it done with. It's not too bad to do it for integers, but floats just a little bit more effort. So I think we'll just scan over every character until we reach the terminator. So we'll reach something that's not a, yeah, this should be quite easy. We'll just go like while text reader peak, something like that, bit of reader. Hey Pete, how's it going? All good here? Sounds like the mic is back to normal. Interesting. I did nothing. But as you can tell, the webcam looks great, doesn't it? Much better. I set up on Windows, and now I cannot touch it on Linux if not the settings get reset. But yeah, so happy about that. Like, it's good size, you know, amazing. Looks good, good quality. What am I decoding? So this system's going to be, so run a little parser for a, this is a custom file. It basically is C, but we have a few little things like, so you can support like packing stuff into 8 bits, right, within a certain range. So it's a way of doing all the manual packing and unpacking code, and a little hex thing to say like, hey, when we encode it out to text, make sure it's in hexadecimal. But so the idea is that we're going to code generate these data structures and code generate ways of taking the data structures and packing them down into files as text or binary. Also ways of just doing the packing and unpacking code generation for networking and maybe GPU code as well, because I found it really fiddly to do it on the GPU and quite error prone actually. So if I could just get it code gen for me and it would just be 100%, it would really save time on dealing with me writing it wrong. So yeah, we just run a general encoding and decoding system that, you know, transcodes data into text or bit packed streams of bytes. So it'd be pretty awesome. It's going to be pretty legendary. It's going to be used basically everywhere. And we need to make it so that it supports versioning as well. That's another thing. It's a little bit more complicated, but I think we can do it. So we're literally just going to say if it's a digit or if it's not a digit. Right. If char equal dot, we just want to know if we've found a dot or not. So this would be like found dot equal true. And if we've not found a dot, or we have found a dot already, we're going to error and be like, hey, there's two dots in a number. That ain't good. So we'll be like, yeah. Why is that a tab? \t. In. Who the crap does that? It's a new line. Multiple decimal places in floating point literal. So that'll just be, you know, hint 123.456. So we also want to say if you come across like an, you know, so say if there's a So you can't come across an F, it's got to be after the decimal place, right? But right, that's a little suffix in it. Okay, invalid suffix, I guess. Right, so the next one we want to say is if it's equal to, see if we just put like F. Yeah, there's like U and all these suffixes, isn't it? So I think we should look for all the suffixes. So if there's an F, I wonder what we should do. If there's an F, we would like to make it float instead of a double, I guess. But see, it's always going to be. We could just end the literal here, I guess. Yeah, so I guess we could do all the suffixes here. Bit of a U, bit of an L. Oh. Oh, someone was already trying to advertise about viewers, and the bot got them. L and then L. So basically we should probably have a way to advance and grab the next one. Is there a way to do that with the text reader? Does it get me the next one? Does it then? Right, I guess we peek it after, right? Do a cheeky peek. Right, so after that we can just say if that's equal to L and advance it. See, I'm not sure if we're really going to use these things. We're just going to put it in as like a 64-bit value anyway, because it's just like it doesn't actually matter, right? We're not doing operators on this, like, you know, but it's good to parse it up anyway, and keep true to it being C, like, or being C, right? So we're just gonna do another one. You know, it's clearly the best code you've ever seen. Parse it up. So I think if we've got something else that's probably like a non whatever character, we want to say if it's, so up here we should probably say if it's one of like these special delimiters or something, if char equal like space, or we should probably say if it's a digit, a dot, a U, L, or F, then let it go past, right? So we'll go if is digit, yeah, if is digit, or char equal dot, or char equal F, U, or L. I think that's all of them. Then we'll let it go past. If not, we're going to continue. So we'll just knot this whole thing. and then get it to continue if not. Wait or break. Something like that, maybe. So we'll not this whole thing. Nice. Right, so what else are we missing now? Vector expression. Oh shoot, this here. Right, so if we just allow us to pass all that and then we just say like, oh, invalid suffix basically. Is valid equal false maybe? And then, so if it was just a U, yeah, okay. So we say if it's not, if is, else if is is digit or is ASCII. Wait, what is? Did I do something really dumb here? Yeah, what I mean is like is alpha, not ASCII. This is a bit dumb. So I should change that in the entity generator. Oh, very good naming there. Yeah, so we say if it is a digit or is alpha, then maybe we'll say, you know what, that wasn't valid, right? So maybe we'll default to true. So we will just do a scan over it, right, and find like a range for this number to parse. Just make sure it's valid quickly, and then send it into the appropriate string to whatever functions, and that will just make it a lot easier to get the job done and know it's correct. You know, we're not writing like a proper compiler, so we can just cheese out on some of this, you know. So if it's U, if it's L, cool. And then I think if it's around, is it digit or alpha? You wouldn't get some other alpha here. We won't get that. So we'll say if is not valid, and then here we can just put in the lovely invalid suffix basically. Is valid suffix. As the L is also going to be a similar one. That's not finished yet, neither is the F branch. So we should be able to just say like, oh, invalid suffix, invalid suffix, hint 1, 2, 3 F, right, 1, 2, 3 U, 1, 2, 3 UL, 1, 2, 3 UL, 1, 2, 3 L, 1, 2, 3 LL, right? They're the suffixes. The T is gone. Right, so if is not valid suffix. So for the L's, it's basically the same thing, it's just another L, right? So we'll just plop that in there. And then, so for the F, after we've grabbed the F, we could do an advance. And we'll do a peak, and if it's one of those digits or whatever, then we got ourselves a problem. If it's a digit or an alpha, it's a problem. Because it's a suffix. Cool. Right. That's not the worst code you've ever seen, I hope. So we still haven't actually got the digit part yet. And told that one to carry on like it's okay, you know? So if we've got a dot, found dot true, we should then continue. Right, go back up and advance. Or we should advance, right? So we should probably say go to continue. So we should probably have a little advance to the bottom. And we should probably say continue. Or maybe I could call that next. Right, be a bit shorter and more distinct naming. So here I'm going to say go to next. So we'll advance. That's going to do the suffix processing. Then a very common one is the digit. So if is digit char, then we'll just simply go to next. Or we're going to accept this one and carry on. Right, so I think that's it for basic, like, so we're able, if we take any number string that's C compatible, we should be able to scan over from the beginning of it all the way to the end successfully, and we should get an error from multiple decimal places, incorrect suffixes, and what else? Well, maybe we should accept ASCII, alpha right here. So digit or alpha or full stop. We don't accept underscores. So in the else statement here, we should be able to stick one of these down as well. Here. And say, well, if it's a digit, or if it's some other alpha character, put a false in there, that's an invalid suffix, right? Yeah, so we could have a bit more of a nicer error message, but I've got the line number and column, so it'll be good enough. I can't be bothered to do the rest of that. So this should hopefully parse digit and get the start and end. But we haven't actually turned it into a number yet. But we know if we found a dot, if it's a double basically, right? Now, if we found a suffix, we actually so you found a suffix as soon as you've gone into one of these, right? So what we should say is found suffix equal true. And then on the, that's an error, well, it doesn't really matter there because it will error out anyway. But here it does matter. We're going to put in and say, well, we didn't actually manage to find a suffix this time around. And then when we get here, we go, well, if we found a suffix, then we're going to finish. Yep. Something that we did miss, that's for sure. Okay. What else could we be missing from this number parsing code? Yeah, so we found a dot, we know it's floating point, but we don't want to be taking up the suffix as part of that. So we need to basically keep a start, some form of like start index, so reader, cursor, or like the start cursor, right? And then as soon as we hit that suffix, we basically should put down like, so like as soon as we get here, so we do like. So I wonder if we should do it every time we advance. So when we advance, we also stick down the new cursor. And if we did that, it would never reach here, right? Because if you found or whenever you found a suffix, it would never set the new advance. So I think if we literally just set the end cursor, I think that could be alright. So we would go end cursor equals start cursor. Now, so this parse number, just to quickly double check. Ooh, yeah, so if you don't find a digit, yeah, so we need to put another one where it's like, expecting number here. That'd be another error. If the start cursor is equal to the end cursor, we was expecting there to be a number here, but there wasn't. But maybe the code that's calling parse num should do that basic check. Make sure the next one is a digit. Because then you could do it more specifically. But I'm already doing it in those places. Yeah. Let's just put it in here. It'd be a bit more effort otherwise. So we're just going to go ahead and say, expected a digit or expected a number here. Now we don't know exactly what number it is because we haven't really got the context of what one they're expecting. Or do we? Type out so we parse a number. This basic type, we just look up the class to know it's a uint. Yes, this one must be a uint because the B is saying like how many bits. And then the next one make sure the type classes are the same and that's it. So the specific type is not really a problem. I don't really have to be super specific about that. But yeah, it's all add. Wait a minute, can I not pass this into the function? Then I know. So if I pass into the parse num function, I go, hey, I really want you to be this class of thing, right? I want you to be a uint. I want you to be a. But then these error messages won't be as good as they are. But I can still pass in the class that I want. And then that way, if they didn't provide it, I could provide a better example. Hey, computer bip. Want to talk? That's cool, no worries. How you doing? How's your day? What you been up to? What are you working on? But then, if it's not that class, it's a problem. I'm not going to bother doing it. I'm just going to say, expected a number. Hint. 1, 2, 3. 1, 2, 3. 1, 2, 3.456. Right. All right. Something like that would do. Right, so after we've done all that silliness, right, we have a start and end range, right? So we're literally just going to be like, well, if we've found a dot, it must be a float. So we'll just do the whole string to double, give it the string, so that's text reader. text reader text index with start cursor, and take the lovely address, and then the end pointer, pointer to the end pointer. Oh, it will return that to me if I want. Yeah, but it should parse all that. I'm happy. Right. So then we'll get back our double. So we're going to put that right into the value. So say value, what is it? Value out, is it? Yeah, value out, float, set it. Yeah, so it's a double, right? F64. It's just a union, so it could be any one of these guys. Then we give it an appropriate type back out. Then we'll say basic out, and we're just going to say, you know, that's basic type F64, even though it could have had the float literal thing on the end. It doesn't matter. That should be good enough. Oh, type out it's called. Yeah, so the next one is like, oh, so I haven't handled hexadecimal or negative numbers. So we've still got to do that. So the next one is string to I. See, these are a bit of a bugger to be honest. String to long or whatever, right? This is extremely dumb. So there's a string to UL, so you can't really get, there's not really a cross-platform string to U64 basically. So on Windows you have to use the ULL, right? Because a long is 32 bits. It's the same as an int. So we'll just have to if-def that basically. So we'll be like string to Are you on Windows now? No. What makes you think? Do you think KDE looks like Windows? Hey there, welcome. Ooh. Yatazak. Welcome. Hey, glorious sir. How are you? Yeah, not doing bad. Bit tired. But yeah, it's been really busy, you know. Every time it's my lunchtime or something, I'm like, oh, I've got like 50 things to do. So many things going on. But you know, lots of good things going on, but yeah, too many things. But doing good. How are you? How's the rendering going? Because I know you've been starting on that now. Grog Brain Dev, am I winning? Yeah, we're winning. We're nearly written out the meat and potatoes of this parser. Got to test it all out, but it should run all first time, you know. I'm sure, right? First time, as soon as it compiles, it's guaranteed to work. What am I making? Are you just coding? Not making a game. What's up? So we've got a big project, but you know, it's going to be awesome. So we've currently got a ray traced scene of ellipsoids with in-compute shaders. We've got an entity component system that's kind of, yeah, that's like built around it being on a sort of tiled map, and I do have bugs, obviously. Built on like the fact that it's like a tile grid, and entities are pulled based on the regions. This is what you're seeing is a 3x3 grid of regions. The regions are very small though here. But yeah, so we've got this like PBR rendering system with ellipsoids. Currently with the big major task that we're working towards, it's probably going to take a year, is build an editor so we can like make models and things, like custom models out of these ellipsoids. But we're doing a bit of the groundwork at the moment, which involves making a encoding and decoding system, which I've actually thought is going to be very useful for many things, not just saving and loading files and keeping versions between things. sorry, not just saving and loading files and making sure that you can have versions of things and things can update safely and preserve game assets that I've already made and stuff like this. It's also going to be beneficial when I want to pack data on the GPU, because I've already done this sort of like BVH, that's sort of a custom packed thing. Rather than doing a very error prone manually packing it, I can use this encoding system to code gen me the code, and it should just be, it shouldn't have any bugs, right? So that'd be cool. Yeah, so super excited about the system that we're building now. It's going to be beneficial for saving stuff to disk in text or binary, GPU bit packing, and networking whenever we get to networking to like pack stuff down. So yeah, this is the general high level of what's going on. Yeah, thank you. I appreciate it. May I ask you a question? Hey, as a real. Yeah, sure. You can ask away. I definitely don't mind helping out. If it's want some advice or something, no worries. I'm not blurred anymore. I know, right? That was incredibly. Basically, I got to set up on Windows using their special software and keep the settings. And if I click on, if I open up a properties menu in Linux about to do with the webcam, it will like reset back to the defaults, which don't look good. But I think the defaults don't look good because it preloads a previous profile and only sets some of the settings. And it might set the manual focus on and then put it at 0 or something. I don't know. Just guesses. But yeah, we want to build content and then like go back to rendering at some point. But yeah, this is the reason why we're building like custom editors and things, so we can make our own models and things. It's gonna be cool. It's gonna be lit. Well, it'll definitely be lit after we return to rendering. I'm sure about that. LIT. Do I have like an OS Windows thing? What do I do with these things? There's a thing, right? That's in main, right? Where's the thing? It might be in the header file. Ah, here we go. Alrighty. Ah. Alright. If defined OS Linux. So for Linux, hash define string to U32 by U64. Wait, I could just use U long long, because no one uses 128-bit types. Boom. U long long. Ta-da. Then the, what is the radix? We'll get that in a bit. I forgot that, we've got to get it. So that'd be a U64. Now, if it's negative, yeah, you apply the negate afterwards. Yeah, so you go if is negative, which I still got to do. What you can do is you put that in that one. Then you open it up as it's a union, right? So you read it back as a. It's a bit dumb. You don't have to read it back, but this hasn't got to be the best code. It's just a code generator that one runs, and just does a little job. It just negates it and kabam. My one issue is that the negative number tends to be bigger. Oh wait. Yeah, I'm not sure if I'll catch underflows or overflows. Yeah, I gotta be careful. Wait, I did write some code. Yes, I remember those horrible if statements I did. Verify basic value. Right, Zavaganda. What's this do? Right, I already verified in here. The past me has helped out present me. What a good lad. So after I parse the number, I verify it there. Based on the... Hang on a minute. What are you doing? Yeah, but the basic type that it's getting is not going to be the one that is here. Yeah, the basic type we're going to be passed in is the unpacked type, the U16. Right. Pass me nearly tripped present me up. What a joker. Yeah, so I need to be using the unpacked type. So when we go back to that encode file, so it reads a little bit easier. So these two values we just read up using that lovely parse num function we just did. We've got to make sure that these are in the range of this U16 unpacked type value, right? And that's what we just made the change for. Right, what's this final one? Wait. Right, hang on a minute. This one is the B8 bit. So that can just be a basic type U8. Yeah, we've got one of those. Neat, so that'll do it. So back to where we were, that was at the parsing code. So we've got to look for the negative value thing to negate it. And then something like that. Right, so basically I'm a Java web developer, interesting. The back end. As sorts right now, I think I don't really enjoy it. I want to make an interesting side project, but never sure if I have enough theoretical knowledge among things that I like, for example, a parser. Right. Okay. So my question is, when you first started very maths intensive project like yours, when did you know you had enough knowledge to sort things out? I have issues where I'll have have a programmatic book about plus one for linear algebra, one for yeah. So you might be a book person, you might not be a book person. You're probably a Gen Z like me. You know, we don't read books. I guess some of us do, the smarter ones, but at the end of the day, you have a certain set of like things which are easier for you to learn. For me, the easiest way to learn is not to worry about all the things that I need to know. I just walk. See, clearly I don't know enough. Look at all these bugs. But yeah, so don't be concerned about all the things you don't know yet. The way that I learn best is I learn by doing. So if you don't know how to do something, you open up the internet, right? Flop open Google, and then you just Google like what you want to learn about. We need to learn about said thing. So you're probably better off making like, so there's, building like a little prototype of something. Like, so you said you wanted to build a parser, was that right? Um, you know, um, so there's little, I think there's that, uh, what's it called? Hang on a minute. I forget the name. Craft Interpreters, that's it. So there's a little online blog. Oh, for crying out. All right. My program's studying the mouse. There's a little website called like Craft Interpreters and stuff. where the book is online and you don't have to like the book is literally online for free that you can, yeah. You can go through and do the exercises and learn about how to build one of these things. And after you get so far, you'd be like, you know what? I understand how to do it. So you can go off and then start building more little ones and test things out, or you sort of have picked up the lingo on how to search for more advanced or more specific subjects within the subject of a parser. So there's plenty of resources online for things. I find just when I have a problem with something, I first start with a basic tutorial, and then I'll pick up on the sort of the language I need to know, and then be able to sort of traverse the internet for better sources there. But I won't worry about needing to know everything about something in order to begin actually producing, a parser or a game, because these things are, it's quite difficult to learn about something without really having a bit of a bit of a bit of experience, right? When you got the bit of experience, you're able to read a bit of theory and be like, oh, right, that thing is this. You've got a picture in your head about it already. So without, like for me at least, I can't really build those pictures in my head too well if I haven't really tried to do it, and understand it that way. Yeah. So make sure you build like small little throwaway projects because they're the best. The best way to learn is to have a little project you can just start writing in, right? You write all your crap code in there, and then like next thing, when you've done it, because maintaining code is long, refactoring code is long. So just write up some code, test some things out, and then be like, okay, I've learned these things now. Literally open up a new project and copy paste the things that you like from the old one and then just start again. But this time you're learning something else, right? And before you know it, you would have refined your skills and have different versions that you've tried. And you could be like, this one worked out really well, but when I did something in the next one, it wasn't as good. And then you have history of that. Um, yeah, yeah, especially around parsers. Parsers get long. Like this one's like already 1,000 lines. Well, actually, no. Sorry, I've got the entity one in here still, which I need to get rid of actually. But yeah, parsers do get long. They get like 1,000 lines. So they can become like thousands of lines. So yeah, when you want to re-architect a whole parser, it's it's a lot of it's a lot of fiddling, a lot of refactor. You have to first get your feet wet to learn swimming. Exactly. Yeah, that's a good way to sum it up. For example, I have compiler principles, techniques, and tools from 2006. It's like 1,000 pages every page. Try to take a note, but I feel like it's taking ages. Yeah, so you'll be able to understand that book way better when you've like got a mental model around it. Just start doing it. Hey Travis, how's it going? How am I doing? Also agree, never be afraid through. Yeah. Yeah, see that's how I learned Vulkan, right? I just literally just tried many renderers that I just threw out and started again. But yeah, things are going alright. I've just been trying to design this encoding system and think about all the things I want it to do. Um, but yeah, just been super busy, super busy. You know, how are you doing? How's your project going? It doesn't render as Vulkan renders before for the same reason. Yeah, Vulkan's one of those projects where the complexity is high enough that you just want to throw it out and start again because it's just quicker that way. And then copy paste the bits that you like from your old renderer. I want to get a bit of a radix. So first radix is 10. Right, if text reader compare C. I already use this one. 0x. Then the radix is 16. Now this will end up accidentally doing radix floats, which I don't think... Sorry, hexadecimal floats, which C doesn't support. But it's quite funny though. And then like there's... If you just have a 0... Hey, what was that? Oh, the read untils, that's it, isn't it? It's okay, we'll do the sure. If you just got a maybe an 8 for octal. So if the radix is not 10 and you've got, that's another, the radix is not 10. Radix not equal to 10. And we have a found dot, right? Floats must be in decimal. And not 0x123. Yeah. Oh, it's gone along well. Currently refactoring assets and resources, etc. Cool. Prime example, throwing stuff away. Amazing. Awesome. I heard you were doing a game design. How did that go? Have you got like a game in mind to sort of make with your engine now? I'm neck deep in learning more advanced network programming right now. Awesome. Yes, that's always the thing I want to do. I think I want to do it very small scale for this project, probably peer to peer. But yeah, that's really cool. There's also a lot of trial and error, I guess. That's just how it is for any topic. Yeah, I would say. Yeah. But yeah, network programming is one of those things where I want to learn a bit more of. It should be networking then audio, I think. I don't know nothing about audio. Yeah, it's going to be similar to the endless runner, but multi-leveled, right? With vehicles and melee ranged combat. Oh, melee and ranged combat. Okay. Yeah, so it's a nice like confined game that you can make. Yeah, that you can make in your engine basically. It's a good idea. Oh, you did a TypeScript game series as well? I didn't know that. I didn't know your Vulkan stuff. Yeah, exactly. Yeah, there those sorts of games where you have like you literally just imagine a room or like a box, something like that, or a little arena. Those sorts of games where they just fit in a little arena or very short-lived levels just are a lot easier to make. As soon as it is not that, definitely a bigger project. Um, right, there is the negative as well. Compare will do the advanced, right? Good. Ball is negative equal. Right, I didn't do the negative float. But do I care about the negative float? Wait. Hang on a minute. I could just use string to LL, right? Because that supports the negative character, doesn't it? Which means I don't have to worry. Yeah. I don't have to worry about. Yeah. But I thought the whole point of these whatever systems is they support the 0x syntax, right? Because numbers. Yeah, it reads that as a. It does read hex, and it reads octal. So I don't really have to worry about that. Amazing. So really these radix things, or these bases. If 0, then base is determined by the format. Boom. But we still want to... See, in string to double, they do that silly thing with... they support 0x, right? Oh, I saw that in the string to f. Right, I think we'll still parse the radix, though, just for that float error. The negate, what we don't... Oh, I think... yeah, we'll keep the negate there. But basically... Where's the start and end? Yes, the start and end before we parse any of this. So we'll go over the digits and stop when we reach the end of the sequence, right? And then we'll just throw it into the existing functions to do it properly. So it'll just be less buggy and we'll get this thing done quicker. So we know, right, if is negative, instead we could just pass it in directly to we can just throw it in there and just pass it directly into the string to long. Right, so that should be the parse number function. We should, oh wait, 0 for auto magic. Working out of that. Cool. So I think that's parse number done. Let's move on to the next section. Right, so I did forget to do default values for so we have an equal symbol. We actually want to parse up this default value. So we need to do that. So equal symbol. Yeah, so all we want to say is like, well, if you're equal to an equal, then yeah, I do have a compared chart. Right, that must be good enough. So let's get back to where we were. Right, so it's equal to an equal symbol. We want to parse the next set of white space. And then here is like, is what exactly? Like, we want to get the, I think, yeah, it's just a string for the field. I think we're just going to copy and paste this string into wherever it needs to go. I don't think we need to worry about it being the right type, because, yeah, we don't really know every type when we code generate this code, right? So what we should do is parse all the way up until we reach some other just read until we reach the space. Wait a minute, this ain't good. No, because you could be parsing up like yeah, maybe we should parse up until we reach just a semicolon. Or a close bracket or something. And then that'll be the default value. And then if it's not equal to that, then there's an error. That can work. Yes, my concern is, why is it looking for like a tab or a new line? These things shouldn't depend on new lines in that. I did a long time ago as the first series, fair play. I just plan on revisiting that at some point eventually, probably with WebGPU. Huh. This stuff is eventually on my list of to-dos to get rid of all the clib calls in my parser string logic, right? Have you got parser? What sort of parsers do you have? Do you like parse like text files up and things? But yeah, I think I have mine in my compiler, but it's, yeah, for a token, yeah. Well, yeah, it wasn't really worth bringing over, I think. Hmm. So, yeah, I don't think we need tabs on new lines. Here, read until tabs on new lines. These shouldn't terminate the process. Or that, just in case. So, oh, it's the ident though. Hang on a minute. You need to stop at these. You need to stop. This is where a tokenizer would have helped out, but it's alright. This was quicker. Hash. So we come across the hash. We can still don't want the hashes to come. Oh, the hashes should come after the default value, I think. Yeah. So these can also stop at hash. Um, right, I think that's good. Cool. So I think that's the string. That's the structure fields code all done. So now we just got to get the we got to do enums, which is basically copying and pasting this code and just taking features out. So this should all be able to be parsed up, and so should this one. I think we might have missed arrays actually. We might quickly double check that one. I think we've not handled arrays yet. But yeah, then we'll do the enum, and then we can start testing it out, printing it back out again to make sure everything's all good. So let's look at arrays. So after you take, so they're only really used in the structure fields. So after you parse the type, we can, wherever the hell that is again, parse type. So after we parse the type, we parse the ident. There could also be array levels. So it's another one. The array comes first, then the default. So now you skip any white space on your lines. If open array, yes, this will then skip white space on new lines. Then this block here would either be an actual number or it's going to be a field. And then we search up, find the field, make sure it's it does exist. Or maybe we search it later. Oh yeah, package managers. I remember like when Rust had a package manager, it wasn't that bad initially. But then like I remember when I tried to do like HTTP and I was like, okay, I'll grab this package or whatever. And then it brought in like 100 packages. I was like, okay, this is crazy. But it didn't used to be like that back when it first started out. I've made a few parsers. I made one for custom storage format. This is kind of like JSON. Awesome. But a few other utility methods. And a custom wavefront OBJ and material parser, based stuff like that. Cool. Anyone where I did a proper tokenizer and such. Alexa was the KSON format I made for storage format. Basically, worked out nicely. Cool. Big old switch tables for the most part. Awesome. Yeah, you see, that's what I typically do as well. Is I have like a custom version of JSON where it's just not, because JSON's really silly, right? JSON is like, well, keys have to be in strings, and then like, you have to have, you can't have trailing commas. But then like JSON 5 kind of fixes that. But then like, you don't get like type names in there or, you know, and that's what I've done in the past. I just made a custom C like JSON and then just like did that. It just works out way better. Like a lot of people just use JSON for stuff and I don't like I understand why because they want it to work across many languages and stuff, but you know, or they want to use it with different tools. But I never really have that problem. Yeah, I guess it will all become like npm, and unless unless they're like an in-house package manager where you have strict rules. But it just takes for the company to get sold out and people to forget why before the package manager gets hooked up to GitHub or whatever it is. And people can get anything with ease. So I think we just need to check if it's a digit. Let's go to the array type. So VLA ident. So if so we check if it's a digit. So VLA ident, and then we should check all the previous fields, maybe. You know, I'm going to keep the thing where it has to be in the same order. Or whatever, like C, you know, in the order that you declare it matters. Because if not, it's just not like C. So it's got to remain very close to C as possible. So if we pick up, we peek, do a little bit of a cheeky peek wherever. Got a char yet? No, we haven't. So char equal text reader peek, and we're gonna just have a look at that and say, you know, if it's a digit, then I guess we'll say, you know, parse the number. So we need to make that array type. So we should allocate the array type. So core stack push generate arrays. And then we definitely want to zero everything just in case. And then we want to say, right, the element type is equal to whatever the current structure field type is. Easy peasy. And the next one is the element count. Well, that's default to 0 because we zeroed it. But here we're going to do the parsing, so we parse the number. Now we want to get all the bits and bobs out there. So I need to find something like this. Well, something like that. Basic value, basic type. Right. So we're gonna take in the reader, parse the number. If it's not equal to an unsigned int, then we have ourselves a problem. So we're going to go ahead and go, well, the array array element count must be an unsigned int or a variable length array. And then we'll do a super lovely hint. And the hint is going to be, you know, U32 field 32 or 64, whatever. Or U32 field some other field, and voila. What a lovely hint. Yeah, so the other case, right, so then we know that in the union, it's just the uint field you can read out and boom. You know, it could overflow, but that ain't gonna happen. Because I think that's U32 or whatever, but elements. Now the other one is like, well, this must be a field name. So we parse up the string. So we want to read until there's a space or something. Wait, we had to parse a verify identifier. So we want to do something like this again. But here. Might drop a comment there. If array type. So we're looking at until you reach a close at least. What else? A close or a space or something like that. There is tons of different symbols as well, I guess, you can accidentally put in, but no worries because it'll get verified. Then after it gets verified, we put it in the array. Nearly had copy paste bugs there. VLA ident. Then we're going to verify which field that is. So I could probably as well put a field index in there, which would be helpful. VLA field index, because we're just going to have one per field, right? That has a VLA. So we should find that. So now we're going to go over all of the previous field indices. Right, strut fields. Right, have we set up the base pointer for those? Fields and fields count. I don't think we set these up. So here, we want to say S for structure, fields equal core stack. Have we got like a, getting like a next pointer or something? Like a, I think in C++ called it back, but what my back is. We want to get like the next, so there's a last, that's not it, because it's a -1. We would like a way to say, hey, what is the next item that's going to get pushed? I could say push 0, but it's a bit dumb. Get next push. This is the problem with get. We can't use a get, that'll be bounds checked. Stack. So address of stack data stack count. Cool. So a bit of a long name, but ought to be good enough for now. Always change it. So the stack is basically gen dot structure fields, and then we set s. Well, s fields will already be 0. So every single time we do one of these, we bump it. That's the s fields count plus equal 1. So it just keeps pushing, pushing, pushing. So now we can go over from the base fields all the way up to yeah, it should be quite easy. I do like the concept of a types of language though. Maybe when I run out of things to do, I'll write one. It's for fun, for sure. Oh, wait, this is in respect to the... Alright, scroll up. So KSON is similar, but it doesn't require. I'll read it here. Yeah, let's do it. KSON is similar, but it doesn't require commas and all new lines for now, but might add comma support in the future. Oh, right, okay, I see. And it supports generic string number, Boolean object array types. The tokenizer basically handles assigning object types on the fly. I haven't got custom types working, but things like a vector3 and I just do xyz as a string and utility function parse string to, right, okay. So it works, serializes for types from case on the horizon. Cool. Right. Yeah. So yeah, formats like text are obviously really good for just being able to see the data, isn't it? Yeah. You like the concept of a type language though? Things to do that I'll do in the future. Yeah, that'd be cool. Yeah, just makes it convenient just to edit it as well. And also version control. Just chucking in there. That's what, so I think all of my files are going to be in text form. But obviously when they are in that release build, they get, I'll just use the binary one instead. But yeah, merging. Yeah, exactly. I think there's really like little point to use binary files for development, unless you're doing like, the only point is if it's going to be super slow. If you do it in text, like you don't do like texture files in a text format. They're a binary file format for reasons. Other field index 0 s fields count, and we just do a super lovely string comparison of everything until we find it. So found equal. Yes, like I want to do a map size of GTA5 and JSON. Yeah. Yeah, they kept adding things to it, didn't it? Like they probably did like events or something and they never deleted them. I don't know. They had tons of things in that JSON file. And they were string searching it every time they were parsing it. Or string lengthening it. So searching over the whole string. It's just so silly. What is GIS data? I've never heard of it. So if, oh, what did I do there? If core string, comparison with structure field, right? Structure fields are the field index dot ident is equal to the array VLA ident. We have found ourselves a contender. And then we just break. And then we go, well, if it's not found, it's an error. VLA with this field does not. Variable length array field this does not exist before, does not exist before this VLA field. VLA count field does not exist before this VLA field. Hint count. Right out loud. E32 array count. Ugh. Yeah, sorry, why didn't I stick that in a not found thing? Why did I just start typing it like a melon? If not found. Right, in you go. Right, so here we also want to set that array VLA field index equal to other field index. Cool. But obviously you can't go and reference yourself. So we take the one away from there. Because you would be able to reference yourself if I didn't do that. So that's pretty sweet. That's arrays sorted out. Wait. So after you've parsed that, we should have stopped here. So we need something like this. So we're looking for a closed bracket after we skip some extra white spaces and things. Right, skip some extra white spaces and things, and then we say expected a closed bracket to finish up the array declaration or whatever, the array declaration. Hint U32 field, 64. Okay. Ta-da. So we should be skipping some white space here though. What's going on there? Right. Cool. So we're nearly there now. We just got one more thing to do, and then we can start like printing all this stuff out and try and recreate the same file from the one that we just parsed. So we've got all of this should be able to be parsed, and all of this should be able to be parsed, right? Including these like these bit packing types, including these compiler directives, including variable length array fields. We just got to do enums now. So we're going to try and keep it as C-like as possible. I was going to like prefix it with stuff, but you know what? I just thought, let's just make it as C-like as possible. So we parse it all up, and then we'll just go and print it all out. And then we can think about what is the next thing we should end up doing. Hey, I don't know what to tell. How's it going? Yeah, the one bag where they had online taking 5 minutes to load because it's, huge JSON file. Yeah, whenever it goes like, whenever it's like a game, like a released game, I feel like it should basically always be in binary. Like, there's probably no reason for stuff to be in text. It's just silly. So GIS data used for the Slippy maps, like, oh. I never knew that was is that publicly available? I love how to get location information, it's like, do I want to use your, that on your location data? Right, I don't know. Excuse me. Yeah, so probably just be very C like, oh, there's semicolons. You have to semicolons. I think I didn't do that. Yeah, we need to pause that semicolon. Expected to finish a strut. Finish up the strut. You know, strut type, you know. Ta-da! Wait, banana. Banana. Any chance you guys put banana? Banana goes in. Yeah, so we need to make sure we obviously have advanced to skip white space in your lines, peak. Right, after that we need to skip some more white space and new lines. Okay. Looking good. So let's go ahead and you know, copy all of this and get started on the enum one. We're just literally going to take stuff out, give stuff a rename, and should be done in a jiffy. That's looking all right. So, enum. We're going to let's look for the word capital strut, replace with enum. Value. And then this S can just become an E. Right, luckily it still supports that like Vim does. Pretty good. E. Sweet. Also another one. FS, so be EV instead for enum value. Okay, let's look for struts. Cool. Right, so now we're just gonna go down and find all the. Wait, there's one more rename I want to do. Which is these guys. So I'm looking for a FS. Right, so be an EV. Cool. So obviously a lot of this code can get deleted. So now let's go over it, change some of the hints and stuff, and some of these error strings, and just delete whole bits of code that we don't need. Or at the very least, wrap up in a binary package of sorts if it's small and text makes sense. Right? Yeah. Yes, that's true. Well, I've got to step away for a bit, but I'm glad I caught up with the stream. I'll catch you later if you're still on. No worries, Travis. Good to see you as usual. Have a good yeah, have a good evening and rest of your weekend. I'll see you on the future one. Catch you later. Bye bye. So we parse enum then ident. Thank you. Enum then ident. And then we can have the hash for like these directive things, right? Yeah, that makes sense. Right. There's that dev thing still. So this is all the same. Then you can open bracket for like, yeah, but the problem is all these examples are just trash. So you're gonna be like banana, I don't know. I guess we like, let's do banana bread. There we go. And they're comma separated. Oh, trailing commas, we'll support those. Yeah, they're optional. This is what's different about them, they're optional. Right, so U32 age, let's replace that with banana bread. Cool. I should say Right. So where did we get to? We got to here. So these would be values. So where it says fields, actually we're going to replace it with values. Nice. Right, so we're parsing the contents of the enum. So we've opened up the bracket. We now, so we bump allocate the values. We location type. That's another thing as well with the location is I think I would also like to store the file in there as well. Do we have that in the text reader? I think we do. Yeah, we've got the file path. I think I want to stick that in there. Because it means I can just pass in the location. And then it's duplicate data. Because it'd be available elsewhere, but it doesn't really matter. Yeah, I think that might be very useful. Yeah, so take note of the location. Now we picked up the enum at, and then what other things do we have in here? So just the identifier. No. Yeah, the identifier of the value. Cool. Yeah, this is the enum value. So the value is optional. But yeah. So we'll have like a previous value, whatever that is. And it does really support negative numbers. So if we do an S64, we'll say previous value, defaults to 0. Or we say next value. So by default, value is equal to next value. And then we simply just bump that, right? But we're allowed to ident size. That's cool. So that passes the ident. So we just need to look out for an equal symbol now, right? So we could really have those directives still. But the directives come last. Semicolons, so it'd be comma instead. Then we don't have arrays, we have the closes, right? So all we're looking for now is we get rid of this array stuff. It was cool though, but it's not needed anymore. We're definitely looking for the equal symbol. So this one will allow us to parse a number. So basically a bit like this one here where we parsed a number. Where is it? There, this code. So after the equal symbol, we parse a number. Just drop that in there like that. We'll get back a type, we'll get back a class. Make sure it's a uint. Wait. Make sure it is an integer. So if it's not equal to that or assigned int, it must be, and it must be within a range of, see, in C, an enum can be an integer or an unsigned int. I could do it so that the enums are always the enums are declared with their own type size and they have to fit within a certain range. That's not really a C syntax, but wait, they are bringing it in C23, right? C23 enum type. Then they add an explicit type for, yeah, they did, didn't they? Right. The C23 has this, so we might as well do that. Because it does fit in with the C language, and it does fit in with things we probably want to do. This code generator. Yeah, so I think you and then by default it'll be a signed 32. And if they want anything else, they have to be explicit about it. So after you parse the name, see, I've got this like U8 thing. I've done it before here where I parse the basic type. So I could put this into a separate function and we just say parse basic type. And then if we, yeah. So basically I reckon we can just parse basic type, pass in the reader, then all of this lovely stuff goes here, and we'll just return basic. So if we get basic type count, that's an invalid value, and then we won't wait a minute. We need to pass in the ident as well. And then we can obviously error on that. So core string ident and voila. So what we can do is nick these 3 lines here. So that was in the enum stuff. So basically, there could be a colon after the identifier. So somewhere here in a lovely set of brackets, there's going to be a way. So we go if the character is equal to a colon. We'll then skip some white space. Then we'll read. We'll read some, the basic type thing, and if we didn't find one, expected a basic type here. Do a nice error. We're gonna make that an equals instead of a not equal. So the ident that goes in is e ident. Wait. Read until something. Read until there's a hat. Yeah, one of these guys. So reader. Hey Bassandra, how you doing? Welcome to the stream, sir. How's it going? Hope your week's treating you well. Performance review at work dries out what's left of my brain. Oh no. So is that like reviewing how well people's actual physical performance is at doing their job? How am I doing? Yeah, not too bad. Super busy. You know, the usual. Super busy. Trying to fit everything in. Yeah. But things are going good. Family's good. Yeah, the boy's great. He's a lot of fun. You know, so much fun. Just, yeah, he started kind of walking now. Like, he's got this sort of like train thing he can like play with. But then he can also like stand up on it and walk around the room, and it's just started doing that today. So it's been fun. It's great. So, yeah, it's pretty cool. Expected a basic type for the enum. For the underlying enum type. English. Good. Hint, enum banana 32. Banana U8, right? Oh, gonna be lit. And then we get the basic. So we need to do a new thingy. No worries. Basic type underlying type. So all it's going to be is E underlying type. Cool. Right, so I'm glad we got the underlying type in there because now we can do range checking of every value that we parse. So basically, like, yeah, after we parse the number, we can do like a excuse me. We can verify the basic value. Oh no, I'm doing Vulkan in here, get out. Thank you, thank you. I have made a small GUI tool with Next Luigi library, but it feels like some stuff will have to do platform specific. Interesting. I've never used it. I've seen it though. You know, well, could you talk about what specific things about platform specific code you'll need to do? See the game running? Sure, sure, sure. Luckily, I still got it going. So we currently just got like a test, cube map with a little test level with these entities made out of ellipsoids. It's all ray traced with compute shaders. Very glitchy still, but this is just a demo for the sort of like entity component thing that we built specifically for this game, because things are going to be broken down into regions. You're seeing a 3x3 of regions, and the regions are meant to be far bigger than this. That means we can pull all of our entities together, and we can do quick lookups by only iterating over the entities which are within regions that overlap your query. So yeah, we built that a few weeks ago. We've now moved on to encoding and decoding stuff now. So we're currently building that encoder decoder stuff. So yeah, what the overall plan though is we're going to be building a set of editors. The first one is going to be a material editor, very basic one, which allows us to change our PBR materials. Just base colors right now, no textures because I haven't got texture support. So we'll just have an ellipsoid that you can sort of change the width and height and depth of, and change the material properties and just view it and save it out. And then the next one is probably going to be the like a level editor maybe, or probably an entity editor, something like that. So you can make models, stuff like that. Because then we can actually produce content rather than just with a bit of maths, right? These have all been done with code. And then when we have content, we'll be able to get back into the rendering and try and make it so we can actually have levels without glitches and make stuff look nice. So proper lighting. Right now, it's got some basic lighting. Yeah, things are good. You have a modal editor with a file open dialog with no innate mechanism to prevent interaction with parent window or keeping out of. Oh, right, I see. Right, yeah. Yeah, potentially. That's cool though. What sort of application are you building? Or tool? So yeah, verify a basic value. The type is going to be of E underlying type, and the value is, hang on a minute, basic value value.un equal EV value. So whatever the enum value is, pass in the value, and we hope it's all right. So when we increment our next value and assign it here, it's going to then go into this function and do all the bounds checking. Hang on a minute. 35565. That was dumb. Anyway, glad I caught that one. And the other one is, if you parse a number that's, an explicit value, we didn't really do this right. So if it's a signed or unsigned number, it might just implicitly cast. Wait, type class, excellent. It'll be the same type class as the E underlying value. which we will default to assigned int e underline value equal to a basic type signed 32 int. So when we have right, I got that bit wrong. So you have the basic is not equal to the underline type, right? So the now do an error, and what we're saying is we're going to do a hint. We want to say yeah. We're going to print out a value. No, we'll print out enum value expects a U32 or whatever literal, right? Value, but got a typed value, but got a string typed value. So we'll be like, right, we expect wait. Basic type strings. E underlying type, that's what we expected, but we got a basic type strings basic one instead, right? So the classes have to be the same, right? They have to be the same signiness. You can't put floats in there. And then on success, we're going to put in the value field of ev value. We'll put in value.uint. Right, I think that expected it to be a uint. You know, we'll put the yeah, so that'll be either a signed in or a uint. Okay, so we'll just put right, ev value jobs are good. Right, so we're nearly there now. So that should do, we just got to deal with the commas. You know, these commas, right? Because you can have a trailing comma, but the comma is not required, like the semicolon is, right? The semicolon is always required, but the last one is not required. So we just got to get that logic a bit good. We're nearly there. Seems to be running Linux. Which one is this one using? Just KDE Kwin. Yeah. Oh, you mean for the graphics in the game? I just use xlib. So it's the one that predates XCB, but xlib these days uses XCB under the hood. The problem with XCB is that it's kind of incomplete, and there's some things, if you want to do some things in it, it takes a lot of work, or there's like certain lookup tables you have to build on top of the ones you already had to build for xlib. And some of the extensions don't work. It's just a pain in the butt. So yeah, I would recommend using xlib. Or if you're using Wayland, move over to Wayland. I've not used it though, but xlib will probably be supported for years to come. You know, Wayland is always nearly here, but you know. Text reader, skip, white space, and new lines. I guess, and then I'm looking for a comma on it. Right, so this one's saying like, well. So we need there to be a comma before we can carry on to the next one, right? So it kind of gets a little bit funny, right? So if we find a comma, it kind of goes like this, right? We find a comma. We go to the, we just continue, right? And we allow it to, what does it say again? Yeah, skip white space, new lines, peek to see if there's any more. But if we don't find one, we sure hope there is. It gets a bit funny, to be honest. Because I could repeat all of this. Do we see the white space on new lines, and we ensure that it is a. I haven't say a common or semi-common one. But yeah, probably want to say like well if it's not equal to one of them. Then there's a problemo. So like expected a comma to continue defining enum values, or a close to finish the enum. So if we get the if we do have this, well, it would have progressed over it. So really what I actually want to do is do a peak here. I actually want to do a peak. And then we say peak equal that. If not equal that. So then if it does equal to that, it'll go around to the next one. It'll do the skip new lines, make sure we can have stuff to process. And then we'll process that and then break, I think. Well, we could just break right away here. Not a problem. Yeah, that's alright. Right, so that should handle the last optional comma. And then we ensure that there is a semicolon to finish the enum. Right, so that should be everything. So the next set of tasks to do is literally just go over and dump everything out to standard out. So we just verify that everything we've parsed is correct. And that we're parsing everything correctly. I think I might delete all this now. This is the code gen stuff. For the entity stuff, which I just copied. Very cool. Yes, we're just gonna do all this debug printing. Even production apps like web browsers and Slack Windows stutters when opening and closing them. Huh. I'm not sure. Wait, this does when you open and close them? Mine are pretty alright. It might be something a little bit weird with your setup. Like, something's... What do you mean by stuttery? Like, it kind of works gradually, or is it like frozen for a long time? Right, I'm just going to quickly pop and get another drink, and then we'll write out this, and then hopefully get it up and running. And yeah, we'll see how it works. Right, BRB. Right, welcome back everyone. It's my workstation at work running Ubuntu. Never used it directly. SSH. Huh. Already frozen, but it's not smooth when compared to something like Windows. Huh. Yeah. If you're accessing it remotely, then isn't that kind of the problem? Maybe? Like, could that be the problem that it's remotely? There's something different there. Or maybe is there, it's Ubuntu as well. Ubuntu is usually quite trash. I always have problems running Ubuntu, not gonna lie. But yeah. The reason why that's remote is because it doesn't work well natively. Right, that's probably Ubuntu then. I would recommend installing like Manjaro, like an Arch-based distro where you get like latest drivers and things, and don't get some crappy extra software that Canonical stick in there, like snap packages and I don't know that. There used to be that like bug report thing which would always pop up and be like, "Oh, this background thing has a bug. Report it." It's like I've just installed the thing, like you know, it's just like anyway. It's tons of proper dumb decisions that go on, and some people can't even get past the install process and ah, piece of work that thing. Right, so we could just go over all the structures and all the enums, I reckon. I reckon that'll be good enough. So we go over all the enums and we go over all the struts. So the super lovely core stack. So I'm using Manjaro. It's basically an Arch-based distro. It gets the updates a little bit later. They do package some extra stuff with it. But it comes set up at the box, which is nice. I've done many Arch Linux installs and I just couldn't be bothered to do another one. And I've been using it for years, for maybe years now. This install, I forget when I first installed it, or when I got this machine. It's probably a couple of years now. So yeah, pretty neat. I like it. I don't have many problems with this setup at all. Yeah, enum type. Right. Let's call it E or something. So we're basically just gonna like print out things about it. So we do have that context-aware printing thing, right? Well, we do have E. We do have E now, so E for ident, right? And then we do have the underlying. We could do the underlying type, so EU, and that'd be core string C, basic type strings, enum. Oh, where's our enum? Gen format enum underlying type. Nice. That'd be pretty legit. That'd be pretty cool. Yeah, so I think we can do the context-aware printing. So we'll be like, right, gen format enum equal e, and then we can just go full ham on it. Print format out to the file, which is standard out. I would like to print out enum with the enum name, so it's $EI colon $EU for underline type, this, then a new line, and then that's that, right? Now the next thing we need is another for loop to go over all the enum values. E values count, and then we do a similar thing, but this time with the enum value. We'll call it EV. Values data B enum value. Okay, so here we're doing a very similar thing, but with a tab, I guess. It's a bit of a tab. So I think I've got this thing called like V, and then something I forget. Let me check the format function again. So VI and VV. That'll do. So VI equal VV, comma, and then a new line. Right, and then I'll go over all the values and keep doing that. And then we can basically just do another print format or whatever. We'll just do a a close bracket and then new line. So that, I'll do an extra new line. So I'll just keep doing all the enums, and that'd be quite nice. So we're going to do the same thing for the we'll do the same thing for the strut now. Why Helix? I remember using NeoVim. Because I updated my system, and NeoVim decided they didn't want to work again. There was something to do with the plugins that I had installed, where I think I was based off of TJ's Kickstart, and I didn't update it for a while, and it just broke. Then I tried to update it using that sort of like plugin manager thing, whatever it was called, and it didn't really want to work. So I decided to like just move off of NeoVim because I really liked Vim. I went to NeoVim and it wasn't like that much better. I did like just a lot of stuff that Vim did. The language server stuff kind of worked better sometimes, but then in other cases it was worse than just simple string, where we look up, have a list of strings that it would just would report back rather than a very smart language server thing. So I've moved over to Helix because I still like the modal editor experience. But it's still taking me a bit to learn, probably because I'm not using it every day. So I should really start using it at work because then I'll get to use it every single day and just get better at it. But yeah, Helix is quite good out of the box. There's quite a lot of good stuff it comes with. It's got like a language server protocol, tree sitter built in. it's got even like ways of searching through files and things like TJ's telescope. So it's pretty neat. Like pretty feature complete out of the box, and it comes with a basic config file, which is not a programming language. Right, it's just a config file. It's got a few things which are a bit, you know, like if you do like a new line, no, sorry, a comment, and you do a new line, it doesn't do the automatic new line, sorry, the automatic comment stuff that you would expect it to do. It doesn't have the quick fix menu, so you can't really run a compiler in a command at the press of a button and get back a list of errors that you can just filter through. The strategy seems to be, oh, there's an LSP, so use that. And that's my one gripe with it, is the LSP, because sometimes the LSP is just it's too clever, right? And it just doesn't give you simple strings that are available because of, it's scanned the code and it doesn't see them or something. I don't know. Yeah, it's too smart. But I quite like it. I think it's definitely easier to start off in Helix than it is NeoVim. NeoVim's got a lot of config stuff to manage. But yeah. So we should be able to keep a lot of this, actually. Let's just paste it down here and go again. I never actually used it. It's the one editor I've never tried. Ah. There must be many editors you haven't tried, right? So have you tried like Cocoon? Oh, this is gonna be legit. It's just gonna print out like a charm. Well, if the thing runs, right? Yeah, when it runs, it's gonna print out like a charm. Strut field. All right, so S SF strut field. Right, so we need to use field for F, FI. Oh no, sorry, SI for structure identifier. We don't really have the extra flags printed there though, not gonna lie. We should do that. S the field count. Ooh, found myself a bug. Field index followed by that's cool. So do you like daily run NeoVim, or do you use Visual Studio Code is a very popular one, so it's probably a good guess. Right, so here we're trying to print out the data type. So I imagine it's like FD, FT. I forget. So we go to the custom format. Or FD was the D, right? Type. Then I, then default value. Okay, so FD FI equals FV with a semicolon. And that should be it. So here we go. So let's go and celebrate. Let's get this thing up and running. And let's compare and make sure that everything we've parsed is there and it's correct. So I think we can now go to scripts, encode gen.sh, give it a run. Right, C type don't exist. What? What's C type? Sound like a C++er. That's copied from my entity stuff. You know what I probably did right? I probably like said, hey, do that next thing. Do that suggestion from the language server diagnostics. And it probably was like, I know what to do, it's C type. Because this is C++, right? That's probably what it was. Because I didn't type that. Unused parameter reader, parse basic type. Yeah, that's the problem with it, doesn't really. Yeah, this kind of sucks. Cool, next one. Next value. Right, EV value. Alright, pretty far already then. Looking good. S64. Do we tick it? Yeah, and it's the same bit pattern. So it will work, even if it's U64. Right, it's running. We've got some errors now, but this is cool. Entity layout. The wrong file. Right, so what I wanted to do actually is I wanted to make it such that this was in its own function, so I could reuse it. Yeah, so I could basically like call it multiple times on all the different files that we had in the code base, right? And just do it all in one process. But maybe that would have been better if it was, I don't know. You could do it in parallel really if it was one file per. Yeah, but anywho, ain't a big deal. Oh, for crying out loud, did I not simply move this to the... Right, so it will be in source logic test.encode. That's the file that we're reading. Right, let's see how that goes. Return 0 on success. And take it for a spin. Error expected a number. Right, so line 321. I usually use NeoVim, but I've been really into Z lately for us. Cool. Yeah, I did try Z out for a bit. It wasn't bad. Needs a bit more polish, I think, but it was quite alright. Yeah, I wouldn't mind it. What are you using the Vim key bindings in there? Right, so we go for the test.enc file, right? Line 3, column what? Expected a number, 21. Right, so clearly that messed up. So what? Ooh, 21. 21 is the right, it shouldn't be too bad. Hard to figure that one out. So we had it, so definitely pass the ident. We parsed the ident, verified that okay. Then we skip some white space and new lines. We grab that character, skip white space, new lines. Parse a number. So this is where we put the breakpoint in. And we'll get in there with the GF. Alright, here we go. Get in there with a reader. Where's Charmanji? Comma? Oh. Did skip white space on new lines skip after the 0? Oh, no. Sorry, I'm an idiot. In parse num, we check if it's 0. So, and then it didn't advance it, right? We should have advanced the thing here, right? All right. Let's get back to that silly parse num function we made. So end cursor will be right. So we just did 0x. Yeah, we'll still chuck that in as well. We might return 0. Yeah, it's alright. It doesn't have to be perfect. Right, value space an S32 type, but got a U64 type. Right. Awesome. The emotions all the way. That's cool. Right, so the class is going to mess us up, isn't it? So I think what we want to just say is like, it's just an integer, right? Basic type class. Basic class. UN. Or and. Not equal to SN. That'll be the other way to do it. Right, so now we're on line 12. 9, expected a number. Let's hop over to .enc. Line 12. 9. It's here. Expected a number. Well, somebody did not skip his white spaces. Good old text readers. Yeah, so that is it when we parse a type. We've got this special type called a packed type, so we can do custom packing. So after the first comma, somebody, past Henry, did not skip his white space. So skip white space, do something, skip white space, do something, skip white space, do something, skip white space. Right, be alright. All's be good enough. Segfault. Right, let's hop in there, figure out what's going on. Right, I tried to make an error. But I obviously didn't put a string in there. So, right. Let's look for that hex thing. Or the hash thing, really. Right, so these want the actual, like, comma, string dot size, string dot data. So let's go around, complete this. Oh, an E. Whoops. Right, that's good. So we should see proper error now. Unrecognized directive alias. It's another one, aliases. You know, I might not do alias yet. We can always add it in if we want it. Yeah, I was thinking about aliases. It would be good to be able to rename stuff, but the way we do aliases is weird. I don't know yet. I have them explicitly named like that, it just seems weird. So what we're going to do is just do something like that. Oh, duplicate field names. Somebody did not check for that. So we got all the way down to alias. We're pretty close. Let's do that duplicate field error thing. I didn't have that one. We need to do that. So structure field, go over all the previous fields, wherever that is. Yeah, we did that here. So as soon as we make the identifier, we simply go over all of them, and we say, well, if the other field ident is equal to my current field ident, then we have an error. Duplicate. Duplicate structure field identifier. Put out the string. Start S. No hints required, right? It's pretty obvious what your problem is here and how to fix it. Int casted S ident size S ident data. So I need to do the same things for enums. We'll quickly do that as well. So enums do a verify ident. Right. Well, there's also the, all right, okay. I'm messing a few things up here. We've got to do it for the enum values and enums and structures, right? Did I put S ident in there? Oh. Right, so we need to go back to where we were. There's a strut field one. It's here, right? So this needs to be SF. That's why it's terrible using one letter variable names. Or variables which are like one character different. It's very easy to get it wrong. But yeah, so we want to copy and paste this again and do it for the structure. You make a structure. So you go over all the other so we're just going over all those struts. So that's a core stack count address of generate struts, right? So you have all those lovely struts looking for your S ident, duplicate strut, identifier, and voila. So one more time, and then we should be able to see that in action. Where we're going over at enums. Those can be duplicate. Right about there. So rather than strut, it'll be enum. And rather than this S, it'll be E. Oh, right, yeah, it's cool. Oh, wait. Did somebody not actually check the structure? Gen.enums other index dot. I don't. Right, so quickly correct that bug. Yeah, so for the structure one, we didn't do. No, wrong one. This one. Gen.struts .data. Crap. .data. Rightio. So let's take that through the compiler and hopefully get a duplicate error. Right, duplicate strut field entities count. Perfect, that's what we wanted to test. So we're going to hop back over to the custom file, delete that extra line, and that should be everything. What? So we got some kind of recursive thing that went on. Two, 3, 5. Oh no, 7, 8, 6. Oh, the array type, eh? Also, arrays haven't been initialized yet. I will do that. So where we initialize those arrays, in it, yeah, initialize those stacks. We'll do a stack of array of, yeah, about 16,000 array types. Ought to be good enough. Well, we could just do 1024. So hopefully that works. There we go. Look at that. So, something's right. Some things don't have a default value, so they're just empty. If they don't have a default value, we should really put a 0 in there, doing that lovely sort of C style of 0. You know what I mean? So we should really do the printing. There's FV for value. So what's nice about this is in our context aware printing, we can go, hang on a minute. Field, right, strut field, value, default value. So if the default value dot size, we return that. If not, we'll return cause string from a literal, which will be a curly bracket, 0, curly bracket, and voila. So that'd be cool. So, you know, just saying it's all 0 initialized by default. Sweet. Yeah, so this is the yeah, so we're getting these correct, right? 0, 1, 2, 3. Let's just go to the file and double check it all. So 0, 1, 2, 3. Entity, right? The names are right. It's got the signed thing there, which is cool. Coordinate, health, strength. Right, we're not printing out the packed stuff, right? This packed type is not being printed out for some reason. We should look into that. Defense, yep. Weapon, yep. Nice. Level is pointing to the wrong one. We didn't. That's all right. So when we did the printing, I did a bit of a silly, where we should actually be looking at strut fields field index, and that'll fix that. So same with enum values. Cool. So we're missing. So in that print when we print a type, or type print I think it's called, or print type, or type string. Yeah, so packed, right, it's just in the underlying type. Bit silly. We should be doing it like, yeah, so if the underlying type is a float, and then if it's assigned int, and then if it's a uint. So I think we should switch on the class. Should be quite easy, I think. Switch on type packed this, but the class of it. So the basic type class, or basic class. Yeah, type class, right. So that'd either be a uint, basic class uint, signed in, or float. We'll return a lovely format string. So it will be the name of the basic type, brackets a b, the number of bits, then the min value and the max value. It's going to be nice and easy. So do the same thing for the float and the signed ints, but those ones obviously we use a slightly different format args. So yeah, we just do type packed dot bit count type packed min dot uint and dot max. Right, so how far away are we? Right, so right. So I'll copy that, paste, delete one. Make sure we get the old breaks in there. Yeah, there's only for a break there, but yeah, that's cool. So this would be a bit of a, wait a minute, this would be a Z U, Z U, this would be a Z D, Z D, that's for a 64-bit signed value, and then float. Right, so these will need to be using those S. Well, it doesn't need it, I guess, but there we go, it's more correct, and then float and float. Cool, so that should be the correct printing now. Oh, I missed one. Case basic count break. All right, so looking at that, we got the B8 100 300 thing printed there, which is quite nice. You know, we could align these to so they look better, but it's just debugging, right? Yeah, we've got the entities showing up. Oh, we didn't get the array there, did we? Oh, sorry about that. So array. Huh. Why? Doesn't that work? So if I did like 12. Right, that didn't show up either. You know what? We didn't set the array type in the field then, did we? We just made an array type, but we didn't actually like use it or store it. So after finally doing all that, basically what you would like to do is, so you get your array type index, so you go so array type index core stack count. of generates. Then we will just store it type. And I guess we'll do something like this. So the kind is a pack, well not packed, it's an array type. Then the array index is array type index. So that's what was missing. We wasn't actually updating the type, so it's good that we managed to catch that. And there we go. So it does print it out a bit differently because we print the type first, but you know, it's just for debugging. So I guess I could try and put the 12 in there again. Let's have a bit of a play around and just see if we can break anything quick. Give it a fix. So put the 12 in there, does it work? It still works. Put a couple of spaces in there, does it still work? Right, it still works alright. So the array syntax seems fine. You know, I can stick stuff on new lines if I wanted. Still works. Right. So fields can have spaces and stuff. You know, let's quickly do a duplicate. Well, okay, let's remove the trailing comma. Right. That one messed up. So how did that one? So one is still that sort of semicolon, sort of like I still mentioned the semicolon. It was a bit sketchy, you know. Right at the end. Oh, to finish up the enum banana bread. Right. Also, we peaked that. We should have advanced. That's why. Text, reader, advance. Okay. Right, that still works. It's all looking good. Back to the good old encoder thing. So what happens if we don't put a comma? Wait, let's put a space and a comma, see what happens. Does that work? Cool. What if we don't put a comma here? That should not work. Cool. It's better comma to continue defining enum value or close brace. Nice. That's good. So we put like a floating point value in here, what happens? Just put a dot in there. Yeah, got a float value, right, cool. You know, let's test our float values out. Yep, still a float. You know, if you put like a U there or whatever, an F, like an L, for invalid suffix, you know, you can put some like invalid, you know, weird stuff there and it will tell you invalid suffix. Cool. Yeah, we haven't really tested out the float values though. We can do that down here with another one. Let's call it range or something. You can't have hex on a float type. That's another thing. So we'll pack down a float and we'll be like, you know, so if we did like values like that, it shouldn't work. Right, that's a bit strange. That's to do with the packed type. Right, so minimum is this error. So if the class, right, unpacked value is, what? Null? Oh, these are class strings. Shoot, wrong one. Type. Man. Right, well that's good. So that's saying unpack values are 32 but got an integer basically. Nice. That's cool. That's what we're expecting. So we should really put a dot f in there or something like that. Right, and then it's parsed them up. They've not got anything after there. It's printed those out. Kind of right. Let's make sure it does it proper. Yeah, seems alright. We're just using the C library functions to parse numbers anyway, so I don't have to check them too hard. There was the E syntax though we didn't pick up on. Can add that later if we need it. What else could we check for? Duplicate strut name. Yeah, duplicate strut, done it. Duplicate enum. That's alright. Oh, nice error. Duplicate enum value. Yep. So that's another thing as well. Like, should we allow for the same enum, but overlapping enum values? We should probably do an error on it. Because I think they should be distinct, right? It's a serialization system. But then if you remove one and then add it back in, right? You should be able to repurpose it maybe. I don't know. Stuff to think about, but let's just make them distinct for now because I could forget and we can always remove it if I don't want that. So where we do that searching for the duplicate identifier, we can also do a lovely little check for value. No, not this one. Enum values. Here we go. Yeah. Value. We should probably say .un because it's a union, so it'd be fine. We'll do a lovely comparison, so if it's equal, we'll get a lovely error. So here we've got a matching enum value. You know, this is where we should. Oh no, it's only. We could probably just do it as a UN. You're right. But then again, if it's a signed one, we'll check if it's signed. It'd be a bit nicer, right? If basic class type class of EV E underlying type is equal to a basic class signed. We'll do the signed and unsigned one separately, it'd be cool. Yes, it's like EV value dot unit. Matching enum value Sweet. So let's test that one out. Let's get back over to the encode file. We're going to copy cow, do cow2. Nice. See, my concern is that we might want to always, like the enum values will probably want to be oh, wait, that one didn't. Error did it. Why didn't that one error? I'm doing the check too early. I need to do the check after. We've done the equal. Now I think we should always have an equal symbol. That's another thing, right? I think we should always have an equal, make it explicit because it's data serialization. Having auto-declared enum values might be a bit a bad idea, but we'll leave it for later, I think. There you go. Matching enum value, maybe we say duplicate enum value. But yeah, I think they might have to be explicit. But yeah, let's try it without these two and see if it increments correctly, right? Yeah, 2, 3, excellent. But realistically, we should be able to say minus. And it will say -1, but I think we've failed at this. Right, so printed it out as an unsigned in. Bit bizarre. Oh yeah, we always print out as an unsigned in, don't we? Oh, we should be able to count. That's in print. What is it in? So this is our special print formatting stuff. So $E for enum, value for enum value. Yeah, so here we should put an if statement in and check our class. If enum basic type class generator format enum value. No, for the enum, make it the underlying type. And if the underlying type is equal to basic type class signed in. So I'll do the signed intness. Yeah, but the problem is it went to 3 afterwards, so that's -2. This needs to be -1. So when we parse our enums, there's a next value thing, right? So actually, we should just be able to say basic value, next value, we'll 0 init that to that. Then we can do value equals next value, bump it. Then when we set EV value, we can probably set next value as well to value. And really the bumping code can go here. That should There you go. So 0, 1, -2, -1. Because we explicitly set -2 and then implicitly did -1. Cool. Yeah, so again, right, we explicitly said, oh, -2 now, and then that's -1. Cool. We haven't really got these things in there. We should really print out the we should really print out all of the directives, really. Yeah. That's pretty good. Pretty good. So now that we've got the parser, we can basically code gen whatever we want. We just got to figure out what we want to code gen. We did do a design in the previous two streams. We kind of made like this plan. But I've been doing a lot of thinking since then. Like, I like the plan, but it's definitely got its what I'm trying to do, encoder plan. Yeah, so went over and basically planned out, like, you know, what formats do you want to support, text and binary, right? Text for version control, binary for like release and networking type of thing. Oh, and for GPUs now, because I want this to also just be a packing system for GPU stuff, because I think that'd be really handy. You know, this is all stuff we want to encode, like as files, but also like GPU, buffer and texture data, texture packing code. Be pretty cool. What features do I want? Hard-coded functions for debuggability purposes, code gen, versioning, upgradability, a system to catch errors when I make edits to data types. Because, you know, I want this thing to be able to like upgrade and preserve data, and I think it will be a right bugger if I mess any of it up, right? So if I could have it as foolproof as possible, that'd be pretty great. So with this idea, we took this idea and made a parser for it. It's missing some of this sort of stuff because I didn't really want it in the end. But yeah, so this is like some rules and things I come up with, but so we definitely want a text and binary format writer, so we might just get started on that. Yeah, so we need ways of like writing out a text file for a type and writing out a binary file for a type. So I think we'll probably get started on those and then get some code gen working that just like code gens these sort of encoders and decoders. And then we can go from there on how I want to do versioning, because versioning is its own thing. We can extend how we want to do that. Yeah, maybe we'll just do the text one, and then when we do the binary one, we'll think about the versioning, because yeah, the versioning may impact how the binary one works. Yeah, that's the plan for the next few streams, is in the text formatter at least, and code genning for that. Or text format reading and writes. Code, encode and decode. Right, let's find someone to raid. So our next be on Sunday, right? At 6 p.m. GMT +1, and then, you know, the same old time, you know, 4 hours ago on Tuesday and Thursday as well. Yeah, so for those who have access to the source code, I'll upload that to I'll upload what we have at the moment to the GitLab tonight. If you want to get source code access, if you support the stream via Twitch or Ko-Fi, you get access to the code right there. And there's also Discord if you're going to come and hang out in the meantime and chat off stream. Yeah, I think that's all I want to share for now. Let's find someone to raid. Right. Oh, I got a following. It's Kanji. Leave Kanji a raid. We should get him to share his screen. Comes up with new things all the time. Now he's got like 21:9 video. Right. Have a good weekend, guys. I'll see you in a future one. Thank you all for coming. Have a good rest of your night. I'll see you later. Bye bye.